Section 11.7, Graphing Systems of Equations. So what we're going to do now is we're talking about if we've got more than one equation and we're going to solve for those. So this gets a little more complicated. So I want you to pay attention, make sure you jot down in your vocabulary what those are. We're going to start off with kind of the easy way to do this, and not as accurate, not as good, I guess, but let's just say that we have two equations. So let's say we have this equation, y equals 6x, and y equals 5x plus 2. And what we want to do is solve for a ordered pair, an x and a y, that work in both equations. That's the idea here. That's what we're talking about when we do this. So let's take a look at I guess that was the one up above. Let's look at this one right here as we go through this. Let's take a look at y equals x plus 3 and y equals 2x plus 5. And we're going to do it by graphing because we're good at that right now. We should know how to do the graphs. So look, we've got them both in slope-intercept form. So we know that the slope of that one is 1. Y-intercept's 3. So I can go over to 0, 3. They kind of have it drawn out here for us. And we can therefore take, go 1 up 1 over 1, so I've got this point, and I can now draw that line there. I can do the same thing for the other one, and notice that there is a point where those two cross. That point is right here. The problem with graphing is that if you don't make a perfect graph, for instance, if you didn't use graph paper that's made for you, and your lines are not exactly the same, you're not going to come out with the right answer. So this is not a great method. It's just a method, and if you did a really good job of graphing, you can figure it out. But it's just kind of introducing right now. So let's kind of go on. Let's talk about, there are a couple other possibilities though, so we want to take a look at those. Let's take a look at one here. This one's kind of strange. Let's say that we've got y equals x minus 3 and y minus x equals negative 3. If we rewrite those to get them both into slope-intercept form, this one, if I take x to the other side, I'm going to get y equals x minus 3. Oh, look at that. It looks just the same as that one. Therefore, I am plotting the exact same line on both. So everything works. No matter anything that works for this one works for this one, because really they are the same line. So this would be an infinite number of solutions, because in a line you have an infinite number of points, so we could get any of those. All right, let's take a look at another example. Here's one. It says the buy online company charges $1 per pound plus $2 for shipping and handling. The best catalog company charges $1 per pound plus $3 for shipping and handling. For what weight will the shipping and handling for the two companies be the same? Well, here's my first equation. They charge $1 per pound. That's the 1x plus 2 pounds. The second equation, they charge $1 per pound plus the 3x. Look at this. We've got the same slope for both, one. We have different y-intercepts. If we plot those lines, they are never going to cross. So you're going to get this, and those lines are parallel. They're never going to cross. And you can tell if they're going to be parallel if you have similar slopes but different y-intercepts. You're going to have parallel lines. So these two, there's no solution. There's no number here that's going to be where they cost the exact same amount from both companies. All right. So those are kind of some graphing things, but we're going to spend most of our time kind of talking about this last method. This one is a much more accurate way because it gives us the exact value. This is what you will do a lot of in algebra next year. You'll solve these kind of equations, and you'll do it in a method called substitution. So let's say we have these two graphs, or these two formulas. Y equals 2x minus 3 and y equals negative 1. And so they say, well, what we want to do is substitute in a value so that we can replace it and solve for the other one. So for instance, look at this one. Notice that there's no x in here. Okay, so that's a little bit different equation than what we had before. But we do know if we look at our graph, y equals negative 1 is going to give us a straight line going across. But what we can do is, hey, let's take this and substitute it into this equation here for this y. So if I say y equals 2x minus 3, and I know that in the other one y has to be equal to -1, -1 must equal 2x minus 3. Now I can solve for x. I'm going to add 3 to both sides. I'm going to get 2, positive 2, equals 2x. So I'll divide by 2 on both sides, and I'm going to say x is equal to 1. So my first point, I've got 1. I'm not done. I've just got my y or my x value. I now need to also figure out what the y value is going to be. Now, normally, normally what we're going to do is take that x value now and plug it back in. So let's go back to the equation, y equals 2x minus 3, and plug in 1 for x. So I get y equals 2 times 1 minus 3, or 2 minus 3, which is -1. So my value, my coordinates that are going to work, this is now for my y value, so that would be -1, and my x value was 1. So 1, -1 would be my value. Now in this particular one, you could have just done, hey, the only choice for y is -1, so we know that that's going to be the case. It's not always that simple. Down the road, they'll get a little bit tougher, but for right now, I'm going to try to keep them fairly easy for you. So I want you to try these right here. 3 of them. You're going to solve by substituting. So you're going to take in this one, you're going to put that, substitute in there. Here you're going to substitute in there. And here you're going to substitute in there. So do those 3 problems, and we'll talk about it here in just a second.
Use the force.
Okay, so for the first one, I would substitute in this 7 into y. So I'm going to say 7 equals x minus 4. Okay, I'm going to add 4 to both sides. 4, get 11. X equals 11. So that's my first coordinate. I do know that the y is going to be 7. So there's my second coordinate. Over here, I'm going to substitute in the 2 for x. So I'm going to say y equals 3 times 2 plus 4 equals 6 plus 4 equals 10. So y equals 10, x is 2, so let's put in 2, 10 for y. And over here, once again, I'm going to substitute that in there. So I'm going to get 1 equals -2x minus 7. So if I add 7 to both sides, I get 8 equals -2x. I now am going to divide by -2. Divide by -2. This cancels. I get -4 equals x. And so my coordinates are going to be -4 and 1. All right. Now, those are a little more difficult. I want you to try a couple more of those. So come down here, and I would like you to do, let's do number 8 and number 9 on these. Do those in your notes. Show them to me when you get done.